AP Calculus AB, Unit 8 Day 11, Office Hours. We're reviewing for our test, extra credit. So, not a required assignment, but just something good, some good extra practice. So, this first one, I think I'm going to distribute this as like x to the negative 1/2. And then I could write it as x to the 3/2 plus 4x to the negative 1/2. And then I can just integrate this with power rules. So we're going to bump it up 1, increase by 1, divide by the new exponent, multiply by the reciprocal if it's a fraction. 4, add 1 to it, it's 1/2, divide by 1/2 is the same as multiplying by 2/1, plus c, of course. Final answer, 2/5 x to the 5/2 plus 8 square root of x plus c. You could leave the x to the 1/2 if you want. Number 2, I would distribute this division. So this is going to be the same as x plus 6 plus 8 over x dx, which I'm going to leave as 8 over x instead of 8x to the negative 1 because it's not going to be power rule. So we get x squared over 2 plus 6x plus 8, natural log of the absolute value of x plus c. So I think that's good enough for a final answer. Nothing really simplified about that. Next one is e to the x is the antiderivative of e to the x. Antiderivative of c can't square it is tangent. And plus c, don't forget the plus c on these answers. That's going to be a terrible way to lose points. True, false. So this is kind of interesting. If you take the derivative of the integral, they undo each other, right? And then you just get f. But really, if you integrate this, you get fx plus c, and you take derivative of that, you're gonna get f prime, right? This one, if you integrate this one, you're gonna get f prime plus c though. So these are not equal. This is actually false. It's almost, but this one has an extra plus c. That one had a c, but you took the derivative afterwards, so c was just a number, and its derivative is just 0. Okay, next one, I'm giving the derivative, initial condition. We're going to try and find probably the original condition, the original function, and then plug 0 into it. So f of x is going to be the integral of f prime of x, which is going to be the integral of 6x squared plus 4. So that's going to be 6x cubed over 3 plus 4x plus c. Then we want to find the c value by plugging 2 into it. And set it equal to 30. So that's going to be 16 plus 8. So that's 24. So I'm going to subtract 24 from both sides. C equals 6. So our function is 2x cubed plus 4x plus 6. But now we're going to go ahead and plug 0 into it and see what it gives us. And we get f of 0 is 6. Okay, next one. I'm giving you a second derivative, and I'm giving you a tangent line to the graph, which means you're probably going to find your initial conditions from this. We've done several problems like this before. So we're going to find f prime first by integrating f double prime, which is going to be the integral of 6x dx, which is going to be 6x squared over 2 plus c. And then from this, when you have a curve and a tangent line, they share a point and they share a slope at the point tangency, which is at x equals 3. So that tells us that f prime of 3 is going to have the same slope of this line, which is always negative 2. Or you could just take the derivative of this and it'll give you negative 2, but this is also y equals mx plus b. It's a line. So we're going to use that initial condition, f prime of 3 equals negative 2. We're going to plug 3 into our equation and then set it equal to negative 2. So that's going to be 27. So c is going to equal negative 29. So our derivative is now officially 3x squared minus 29. So we're halfway there. So the original function, I'm going to integrate the derivative of to get, so that's going to be the integral of 3x squared minus 29 dx, parentheses required, dx required. And so we get 3x cubed over 3 minus 29x plus c. Now for this, if you plug 3 into the original, the equation of the line, you get the xy pair at the point of tangent c, which is 3, 2. All right? So that's going to be our initial condition also for our curve. So we can plug 3 into this. And it should equal 2. So this is going to be 27 minus 60, 87. So that's going to be negative 60. So C equals 62. So your final answer is 5x is x cubed. That's 29x plus 62. So we've done a bunch of those. Shouldn't be surprised if you get one like that on the test. True, false, definite integrals, fundamental theorem of calculus. So, I mean, this is true. I think we know it to be true. If you want to support your answer, which I might ask you, you could find the antiderivative, which we often refer to as capital F, and then plug the limits in and show that both sides are the same. Next one, we can't hook these up for a couple reasons. One, the tops match. We need the top of one match the bottom of the other. Also, this is subtraction. But if you remember your properties of definite integrals, you know we could flip this and put an extra negative in front. And become plus plus. And now the top of this one matches the bottom of this one. So now we get 1 to 5 of fx dx equals 1 to 5 of fx dx. So that's true. You gotta support your answers, your true false answers. Okay. So let's see. You could have also done the antiderivative thing there, but that's up to you. I'm okay with this. You gotta just show me some evidence that you understand how you got true or false. So this says that f of x is odd. So you guys know what odd function looks like, right? Odd function is like a cubic or sine. And we're saying we're going to integrate from 0 to a, and then we're going to integrate from negative a to 0. And it says we're going to get the same thing. Well, the area is going to be the same, but one's going to be negative, one's going to be positive, right? So this is going to be false. One of the ways you could draw that picture to help me understand how you thought of it, but another way is we could, fix it to make it true. So add negative to either side. Okay, if it's even, so even function would be like a parabola or a cosine function. So if you go from negative a to a, you have symmetry, right? And they're saying now it's going to equal the same thing as negative a to 0 doubled. And that's true. That is true. Okay, so moving on. Got a bunch of integration problems to try. Bunch of U-Substitution. So, let's see. First one, a lot of times we like to go for the denominator to be our U, or what's in the denominator. I mean, I know there's 2x there, and you could do that as your U, but then you're going to have to do another layer of U-Substitution to finish it, which is possible, but it's a lot of extra work. So hopefully this works out. negative 2 sine 2x dx. Chain rule. Don't want the negative 2. So then that's going to be negative 1/2 of the integral of du over the square root of u. It's going to be negative 1/2 u to the negative 1/2 du. So that's going to be negative 1/2 power rule. Add 1 to the exponent, divide by the new exponent, and multiply by the reciprocal plus c. So that's going to be negative square root of cosine 2x plus c. Don't forget the plus c's on this. So there you go. Next one, you might be like, oh, that looks like inverse tangent or something like that. But, don't make it overcomplicated first. Maybe just go with the whole denominator. It might work, and if it does, it's going to be a lot quicker. And it does. X cubed dx, perfect. I don't want the 4. So it's going to be 1/4 du over u. So that's going to be 1/4 natural log of the absolute value of u plus c. So it's going to be 1/4 natural log of the absolute value of x to the 4th plus 1 plus c. Now, these absolute values need to be in your work, but sometimes we rewrite it without them. If the inside's always negative, you get rid of them. Put parentheses, but an extra negative. If they're always positive, get rid of them. Put parentheses though. You still need grouping symbols, so it's not like less work to write it, but it is simpler logically. Okay, next one, if you picked u to be the whole denominator like we just did in the last one, it would not work out so well because we need x dx, so that's not going to work. So then you start to think creatively in the more complicated ones. Maybe this is inverse tangent. What would you square to get there? You got to have a 1. So make sure that's taken care of first. So your u is going to be x squared. And I want the 2. But this one works because it gives us x dx. So it's going to be 1/2 du over u squared plus 1, which is 1/2 inverse tangent of u plus c, which is 1/2 inverse tangent of x squared plus 1. Okay? Next one, you might, oh, that looks like inverse sine. No, don't try that yet. Just try the simple approach first. Okay? That's going to work. Nothing fancy. So we need a negative 1/2 in front. That's going to be du over the square root of u. So it's going to be negative 1/2 u to the negative 1/2 du. It's going to be negative 1/2. Add 1 to it, divide by the new exponent, multiply by the reciprocal plus c. Final answer. It's going to be negative square root of 1 minus x squared dx. No, sorry, plus c. Okay, next one. U should probably be e to the x. Ooh, this one's gonna get interesting, but we'll try it. Du equals e to the x dx, which looks really good. It looks very promising. So we get integral of tangent u du, but the problem is we don't know the integral of tangent. So now we'd have to change it to sine u over cosine u du. Now, I'm just telling you at the very beginning, if we did that right away and said sine ex over cosine e to the x and picked our u to be cosine e to the x right at the beginning, this problem would be a lot quicker. But we're going to have to do another u substitution. So I'm going to call it v just to make it less, I don't want to use u again. It's going to be the denominator. So dv equals negative sine u du. Don't want the negative. So then that's going to be negative dv over v. That's going to be negative natural log of the absolute value of v plus c. Then we got to change it back to u from v. So v was cosine u. And then we got to change it back to x. u was e to the x. And the inside of this is going to be positive and negative, so we need to keep the absolute values. But if we had used u equals cosine e to the x right at the beginning, it would have been a lot quicker. It would have only been one u substitution. Now, when we do chain rule, a lot of times we would do chain rule over and over again, multiple layers of it. So it seems okay that we could do u substitution multiple layers. But if you pick the right u at the beginning, you could probably pull it off in one step. Either way, now a lot of times I like to just try the whole denominator, at least in my head. Maybe I don't write it down like I am right now, because I might see, oh, I need x squared dx. This isn't going to work. So I probably need, this is probably an inverse sign. What do I plug in here to get x to 6? It's going to be x cubed. That should be my u. This needs to be a 1 first. If it's not, du equals 3x squared dx. Don't want the 3. That works. So that's going to be 1/3. And integral of du over the square root of 1 minus u squared, which is inverse sine of u plus c. I'm going to change it back to its original variables. X cubed plus c. There we go. All right, number 17. I wouldn't jump into U-substitution yet unless you want to do multiple layers of U-substitution. Hopefully you learned your lesson earlier up here. I would rewrite this as cosine 2x over sine 2x. We don't know how to integrate tangent cotangent, or we haven't memorized their outcomes. I don't think that it's worth it. So we could always just use sine and cosine and pull it off. We got to do a little U substitution. So U equals sine 2x, d equals 2 cosine 2x dx. Don't want the 2. We can do this in one step instead of multiple steps of U substitution. This is going to be du over u, which is natural log of the absolute value of u plus e, which is going to be natural log of the 1/2 natural log of the absolute value of sine 2x. We cannot get rid of these absolute values because sine is going to be negative and positive and negative and positive. Okay, next one. This should probably be our u. Let's try that. When you pick your u, you should see the du in the other stuff, or be looking for it. Negative sine x dx. Don't want the negative. Okay, good. It's going to be negative e to the u du. So it's going to be negative e to the u plus c. It's going to be negative e to the cosine x plus c. Make sure you rewrite it back in terms of the original variables. Okay, next one. You might even remember this one might have some interesting issues that we could pull off. You have this extra x left over. That's not good. And either that means you picked the wrong u, or you can't do it, or you can, but here we could write x in terms of u. X is u minus 2. So when I rewrite this, I have a negative out front. No, don't have a negative out front. I have parentheses u minus 2 and the square root of u. Now I'm going to change this to u to the 1/2 and then distribute it. Rules of exponents. So it's going to be u to the 3/2 minus 2u to the 1/2 du. So now we're going to integrate u to the 5/2, multiply by the reciprocal, u to the 3/2, multiply by the reciprocal, plus c. We write it back in terms of its original variables, 2 plus x, in for all the u's. And don't forget the plus c. Okay, next one. I mean, a lot of times we choose the denominator, but if you did that, I would not get you very far. So maybe we choose the numerator. Just got to be open to trying different stuff. And remember, when we pick for u, you should see the du up. Perfect. I need dx over x. So this is going to be u du. So that's going to be u squared over 2 plus c. So it's going to be natural log of x squared over 2 plus c. No absolute values. Natural log was already there. Got to put parentheses around this when you square natural log, otherwise it looks like it's just on what's inside, which means a totally different thing. We cannot move this 2 out in front with the log rules. It's not possible. Thinking about giving you guys a quick little bonus problem here. Let's see if we do this. I'll just squeeze in right here. You can do it on another piece of paper if you want. What if I gave you x cubed 1 over x to the 5th plus sine x to the 4th? How would you do this problem? Now, some people would say, oh, let's just jump into U-substitution. X to the 4th du equals 4x cubed dx. And you can totally pull it off. There's x cubed dx. But involving this guy with the U-substitution is totally unnecessary, and people are going to generally kind of screw it up. So what I would do first is distribute this and say, okay, well, this is going to be x to the negative 2 dx. Do that guy on its own, but this guy gets a 2. And then this guy would be x cubed sine x to the 4th dx. And do the U-substitution only for this term right here. If you try and pull it off here, which is possible, you're probably not going to. It's going to be harder. You're probably going to screw it up. If you do it like this, it's way easier. This is just going to be x to the negative 1 over negative 1. And then you're going to do your du stuff over here. So like it's going to be 1/4 sine of u du. So it's going to be negative 1 over x. It's going to be 1/4 cosine u plus c. Negative. It's going to be negative 1 over x minus 1/4 cosine of x to the 4th plus c. But I mean, the biggest thing I'm trying to get you to pay attention here is that this first term didn't need the U-substitution. Yes, you could involve it. You're probably going to mess it up. It's hard. You're going to get the wrong answer. Distribute it. Make it easier for yourself. Only use U-substitution for terms that really need it. Okay? All right. Got a couple more here. So I'm going to go with the whole denominator. I'm not going to think inverse tangent yet. I mean, it's in my head, but I'm going to try and see if it's easier than that first. And it is. Get the e to the 2x dx. Now, if this was e to the 1x, that very small change is going to make it inverse tangent. Totally different looking answer with a very small change. So I'm going to rewrite this 1/2 du over u, 1/2 natural log of the absolute value of u plus c, 1/2 natural log of the absolute value of e to the 2x plus 1. Now, the absolute value should be in your work, but this final answer here, we can get rid of the absolute values because the inside is always going to be positive. Okay, next one. You're either picking this to be your u because in the denominator, you're picking this to be u because in the sine. They're both the same, so let's just see how it works out. Du equals 1/2 x to the negative 1/2 dx. You might rewrite this as 1/2 times 1 over the square root of x dx. So this is actually your du right there. You're picking u to be the square root of x because of what's inside. So I don't want the 1/2, so we're going to multiply by 2. So this is going to be 2 sine u du. So this is going to be 2 cosine u plus c, make it negative. Rewrite it back in terms of original variables. Okay, all right. There you go. All right. Next one, kind of interesting, multiple choice. It says if you're integrating f prime over f dx equals natural log f of b, then f of a would have to be what? So this is actually a U-substitution problem. You see f prime, so you should probably want to pick the denominator. And then when you do du, you get the derivative of f prime of x dx. Perfect, right? So this is going to be du over u, which is going to be natural log of the absolute value of u. It's going to be a natural log of the absolute value of f of x. Now this is a definite integral, so we've got to plug the limits in. So we get natural log of the absolute value of f of b minus natural log of the absolute value of f of a. And they're telling us that the answer is going to be the natural log of f of b. Now the only way that's going to happen, I mean, that's essentially this term right here. The only way that's going to happen is if fb is positive, okay, and this term goes away. Well, how would this term go away? Natural log of what would be 0? 1, right? Which means that f of a doesn't equal 0. F of a equals 1 for this to work out the way they describe it. So answer C. Okay, we got a little motion review here. Acceleration, initial velocity. We're trying to find the velocity. So velocity is going to be the integral of v prime, which is going to be the integral of acceleration. It's going to be the integral of sine 2t dt. Now you could do U-substitution for this. You could say, oh, well, u equals 2t and du equals 2 dt, and I don't want the 2, so I'm going to put a 1/2 in front. Or, I mean, if you're just like, well, the answer to the sine is going to be cosine. It's going to have a 2t inside. It's going to be negative. And an extra 2 is going to pop out that I want, so let's put a 1/2. Or you could do it this way. Say, oh, there's a 1/2. You're doing all this work just to get that 1/2 that I think you kind of see it in your head. And eventually you get the same answer. Now, we're going to use the initial condition to find the c value. So we plug 0 in. It's supposed to be 3 now. This is 1, so you're going to get c equals 3.5 or 7/2. So your final answer for velocity is going to be -1/2 cosine of 2t plus 7/2. Okay, here's a graph of position. On what intervals is the velocity positive? Well, that would be the slope of this graph. So I'd say A to B. I usually include the endpoints. Well, it just says velocity positive, so probably wouldn't include that. Because it's 0 right there. And then E to G. Probably won't include an E or G because it looks like it's 0 there. Particle is speeding up. So that means when A and V are both the same sign. All right? So here, velocity is positive, velocity is negative, velocity is positive. Acceleration is the derivative of velocity, so the slope of this graph. So here A is positive, here A is negative, here A is positive. So they're both positive here. So I think A to B, we usually include the endpoints for velocity, but not acceleration. And then they're both negative from, okay, so acceleration is the derivative velocity, which is the concavity of this graph. So I messed this up. It's concave down here, so A is negative here. It's concave up here. I was thinking it was the graph of velocity for a second. It's concave up there, and then it's concave down there. So Positive velocity, negative acceleration, negative acceleration. So I'm going to say B to C. B to C. We include B, velocity, and acceleration. It's in the middle. C, we don't because of acceleration. Now, positive velocity, negative velocity, positive acceleration, positive velocity, positive acceleration. So I'm going to say E to F. Now we include E for velocity edge, and it's in the middle of acceleration. We don't include F because it's the edge of acceleration. It's positive velocity, negative acceleration. So those are going to be your answers there. B to C, E to F. Okay. C at what points is the particle at rest? So that's going to be when velocity equals 0. So we're going to say time equals B, E, and G. All right, last page. Got a velocity curve. So when is particle moving forward? That's positive velocity. Well, that's the whole time here. This all the y values its graph. So I'm going to say 0 to 10. Acceleration is negative. Well, acceleration would be the derivative of this graph. So here acceleration is positive, here acceleration is 0, here acceleration is negative. So I'm going to say 7 to 10. Don't include the endpoints. And then slowing down. So they're both the same. That's speeding up. That's neither. Slowing down. Here they have opposite signs. So we're going to say 7 to 10. We would include 7, but not for acceleration. 7 to 10. Total distance. So I talked about this. I think in the pre-test, it's kind of a new idea. I don't think we're not going to put on the test. It's going to be the integral of speed, which is the integral of the absolute value of velocity, which is the area under the velocity curve forced to be all positive, which already is. So it's just going to be a triangle 1/2 base times height plus a rectangle. It's going to be base times height 4 times 3, and then a quarter of a circle, 1/4 pi r squared. So the answer is going to be 9 halves plus 12 is 24, so 33 halves plus 9 pi over 4. Okay. Now, gravity problem. Bill's watch is hurled upward toward the top, from the top of the Batman roller coaster on 25 with initial velocity. So this is your initial position. This is your initial velocity. This is gravity problem. So the equation is 1/2 gt squared plus v naught t plus s naught. You guys should be able to rederive that if you had to, but it would just take a bit of time. So I might go ahead and just memorize it. Now, for our problem, we're going to use g is negative 32, so we can get negative 16 t squared plus 32t plus 128. So that's our position equation. Our velocity equation is just quickly the derivative of this, negative 32t plus 32, and then our acceleration is just the derivative of that, and we should get negative 32. It's just a gravity problem. So those are all three of our equations. So we got the equation for st, negative 16 t squared plus 32t plus 128. And then we should probably go and find the other things like time of impact. Let's find that. I need that for some. I mean, speed is going to be the absolute value of velocity at time 3. We can go ahead and do this real quick. So plug it into our velocity equation. And the units are feet per second. We have units on these problems. Okay. Velocity impact. So we got to find impact for something. Multiple problems here. So impact is when you set the position equal to 0. So we're trying to use some factoring techniques, hopefully. Otherwise, we're going to resort to quadratic formula. Okay. Minus 4 plus 2. Looks like it works. So t equals 4, t equals negative 2. We're not going to have negative time impact. That's just imagining that it was thrown up here, and they imagine it going backwards and hitting the ground. That's the one we want. Okay, so velocity impact, we're just going to plug that into our velocity equation now. So velocity equation was negative 32 times 4 plus. So it's good to label your work. Make sure you follow your work. So we mean negative 96 feet per second is the velocity at time 4. Okay. It's negative. It's going down when it hits the ground. Average velocity from starting point to impact. So that's a whole trip. So we're going to do the average equals, this is mean value theorem, and plug in time 4, plug in time 0, 4 minus 0. Plug in 4, you should get 0. That's how we found it. Plug in 0, you should get the initial height 128. Units are feet per second. And it's negative because more of the path is going down than up. Now this says initial velocity of Shauna's watch tossed from ground level to match Bill's watch's maximum height. Well, let's see. So this is a different problem. We're going from ground level. So that means S dot equals 0. We're trying to figure out what the initial velocity is. So our equation is going to be negative 16 t squared plus v naught t, and the initial height is 0, so we don't have that. So that's the equation for it. We got to find, I guess, Bill's max height, which I don't think we've done yet. So maybe we should do that. We got to find critical points, S prime, which is velocity, which is negative 32t plus 32 equals 0, and define. So you factor it. So t equals 1. This is for Bill. I'm going to plug in points, 0, 1, critical points, impact was 4, into Bill's position equation. Okay, so you plug 0 in, you get 128. If you plug 4 in, you should get 0. You plug 1 in, you get 16, 34, 144. So there's your max. So we're trying to get this other watch to have a max of 144. It's thrown at ground level. So we gotta figure out what would give that. So now the critical points can happen at the derivative of position. And equals 0 or undefined. So that's going to be let's see. That's going to be t equals v naught over 32. So this is the critical point, which I think we can assume that is where we're going to go ahead and assume that's where the max is going to happen. So S max for Shauna should also be 144. And that should happen when we plug this into that equation, v naught over 32 squared plus v naught times v naught over 32. And this is looking really gross. I'm not going to give you something like this on test, but this is good practice. So what do we get here? We get that goes in there and that. So we're going to get a 2 and a 32 there. So this is going to be 144 equals negative v naught squared over 64 plus v naught squared over 32. So we want to combine these together. Multiply top and bottom by 2. And then, so we get 144 equals positive v naught squared over 64. So we're going to multiply both sides by 64. Which I'm going to leave like that. And then we got to take the square root of both sides. Plus or minus. V naught equals, it's got to be positive because it's going to be thrown upward. It's going to be 8 times 12. V naught equals 96. The units are feet per second. Nice. That was fun. The height of the watch when its velocity is the same as the average velocity from starting point to impact. So there's that special thing from mean value theorem that says the actual velocity equals the average velocity. The actual derivative equals the average derivative. Now we already found, I think earlier in part D, that the average derivative was negative 32. The actual velocity, which we have an equation for. So we're trying to find that C value, right? The guarantee of the mean value theorem. So velocity is negative 32t plus 32, and it's going to equal the average, which was negative 32. So it's going to be negative 32t equals negative 64. Divide both sides by negative 32. So t equals 2. This is when it happens. But now we need to plug that into the height function. So we plug that into the height function, which we found at the beginning. We can figure out what its height is when its average slope equals its actual slope. So this will be negative 64 plus 64 plus 128 equals 128. Feet are the units. All right. So those last ones are a little extra challenging, but it's good practice. All right, get ready for your test.